Hello everyone, welcome to my channel again. So today I want to talk about the Leetcode challenge 137, single number 2. So in this video, I think I will assume that you have the required knowledge about bitmap manipulation and truth table. And if you're still not familiar with these two challenges, you would need to prepare for these two knowledge, and it will be more easy for you to understand my solution. So after every time I record a video, I will conclude again the detail to my blog, which is blog.onepunch.com, and also you can see the code in my video on my GitHub. So here's the link. Okay. So before we're talking about a solution, we still need to see what is our number, what is the challenge we are going to face today. So here is single number 2 on Leetcode, and given a non-empty array of integers, every element appears 3 times except for 1. So we need to find a single one that only appears for 1 time. Here, for example, here is 2232 of A array, and 2 appears for 3 times, so the single number is 3. And here, for the example 2, we can see that 0 and 1 both appears for 3 times, only 99 appear for 1 time, so 99 is our single number, and we need to print out it. So from now on, I will start from talking about our idea and looking at the code of the solution. So I will introduce 3 solutions today. And first solution is sort and plus third number equal to first number. So if you cannot understand what I'm saying, it's okay. I will let you figure it out. Okay. So I will take the example of 2232. And so if we want to find a single number, so it means that there is pair of 3. It can be any number. Maybe I will assume that number 1, number 2, and for it appear 1 time, this is single number, and this is another number which appears for 3 times. And so we need to find out this single number. And so how if we just assume that okay, so take this for example. Today we want to find out the single number, and we can let every number just for the same number they combine together, and so we can separate to the number who appears for 3 times, and appear for 3 times, and the one appear for only 1 time. That would be our single number. So how can we do this? We can make sort first. I will assume another more complex array. For example, for 1 1 1, or maybe 1 1 3 2 3 1 3. So first, if we use our eyes, we can already know that our single number is 2. But the not single number is first 1 and 3. And if I want to separate them to the groups, I think you already got what I mean. You can make it sort. Sort the numbers vector. Then you can now get 1, 1, 1, 2, 3, 3, 3, right? So we already combine the number which are not single number to a group. So then how can we find out the single number? So the way we can find out a single number is that we can observe that if they are the same group, if these three numbers are the same group, the first number will equal to the third number. And this, if if there are a group, the first number will equal to the third number, which is the last number of the group. So we don't need to consider the middle number, because we already solved it. So if they are equal, then the middle number must also equal to the group. Okay, so if they are, yes, so we can use this. If here are two groups for which are not single number, then the first number will equal to third number. Then we can jump to the next index, and the first number will equal to the third number again. Then there will be no exception if there is no single number. So now we come out the solution. First, we can try that the first number is equal to third number or not. Yes, they are equal. So, okay, we can go to the next index. Then judge that the first number still equal to the third number? No, because this number is not in a group. And why? Why he is not in a group? Because he is what we want to find, single number. Okay, so this is our first idea. Next we will come to the code, see our code how to implement finding out the single number. Okay, so this is our first solution, right? So I will sort here first. I sort here first to make the same number keep in a group, and then I just need to iterate the nums, and each time when I already make sure that this is a group, then I can go to the next index and check again. Then if I find the first number is not equal to the third number, then that one is the single number. So I think this is just a very easy solution. However, you need to be careful that you might think here is only a complexity of linear time. However, this sort function take big O of n log n times. So in fact, the time complexity of sort function is even more than the for loop. Okay, this is only one single things you need to know about it. Okay, so next I will talk about the second solution. Okay, so our second solution, we assume that our each number will be, oh, you just need to imagine that so in computer our number will all change to binary, that so our number will just become 0 1 0 1 or what, just be to choose of on each bits for uh, either 0 or 1. Okay, so in the element of nonce, in each element of nonce, I assume that I will take this for example 1 1 1 4, or maybe 2 would be better. Okay, and then we change it to binary, 0 1 0 0 1 0 0 1 0, and 4 is 1 0 0. Okay, so in fact this is very similar to first idea, but what is different is that it look from each bit. So even on each bit, if they are not single number, then the one will also if there are not single number, the one will also appears for 3 times. And so it means that if there on the on if the single number on that bit is 0, and the times 1 will appears on that bit will become 3n, right? And if sing if the single number on such bit is 1, then the times of 1 will appears on such bit will become 3n plus 1, right? Because single number, and others are all pairs. So n can be 1 0 1 to n to maybe n, right? Okay. So now the solution is easy. So we just need to make so we just need to count the number of 1 on each bit, then multiply by 3. Then we can get whether there is whether we can get the single bit is 1 or 0 on such bit. So there are only two conditions, two possibility on each bit. One, mod 3 will become 0. Then that means single number on that bit is 0. 2, if count of one bit mod 3 become 1. Then that means that single number on such bit is 1. Okay, so after we iterate all the nums array, you can get each bit on the 1 or 0 on each bit. And in fact, if we change to decimal again, then that would become our decimal number, which is the single number. Okay, so great. Let's go to see our the second solution. Okay, this is our second solution. Okay, so one thing you need to, okay, so here the the largest number will be 32 bits for integer. So so we just need to iterate for 32 bits, and for each bit we will go to see whether the single bit is 0 or 1. So first we will iterate for 32 bit, and then okay, I will start from this part first. So I will talk about again for bit manipulation. For 2, then it will become 0 1 0 2 0 1 0 2 0 1 0 4 1 0 0. Okay, so if it is our first bit, then we don't need to shift, and so I will start from 0 because it is first bit. We write shift for 0 bit, so it will become 0. And we can use AND 1 to check whether the bit is 0 or 1. So here means that if the bit is 1 and AND with 1, it will become 1. So it means that the bit is 1 and we just count number plus 1 because it means that there is 1 bit. So if we talk about the second bit, and it will write for the purpose of AND with 1, it will need to write shift for 1 bit. This will become 1, and AND with 1 to check whether he is 1. And for the third bit, it will need to write shift for 2 bits, and so this is also 2. Then to here we have, for the list loop, we can calculate on each bit, on 0 bit or on 1 bit, the count number of 1. And then we just need to make them mod 3. Mod 3, it will get the number of single number, whether it is 1 or 0. And then if we need to decimal, convert it to a decimal, we just need to left shift back, just because here we right shift, here we will left shift, and use OR to combine all the results together. Okay, so this is solution 2. Next, we will come to the third solution. So before we start on first solution, we need to you need to understand what is truth table and how to get the how to calculate the output of truth table by yourself. Okay, so here we will use stat machine and truth table to solve this solution. This solution is very cool and get the highest, the most efficient time complexity and the most optimized solution for this challenge. So you need to learn about this one. Okay. So what we want to, when we come back to bit manipulation, we want that when two, if we maybe just accumulate or calculate all element together, we want to the number which appears for 3 times to disappear, and the left result is only 3, and then we can get the single number. Same, we want the numbers who appears for the same number who appears for 3 times can disappear. For this example, 0 appears 3 times, 1 appears 3 times, then they can become 0. And then the left result will be our single number. So let's come to the stat machine. Here we can imagine that a number, if a number stat, if it appears for 1 time, it becomes 1. But a stat 1. But if it appears for 3 times, and it will be reset to 0, 0. So we need to find the number which only appears for 1 time, which is stat 1. Okay. Now let's see how to implement such ideas. So let me see. Okay, so here's a number 3 times. Single number appears for only 1 time. Okay, so it means that there is several states. First initial state, because there is 0, 1, 2, and when it becomes 3, then it will reset to 0, because we want our number which appears for 3 times to be disappear. So this is his stat machine. Okay, so to get how to calculate the state machine, how to calculate the result from the state machine, the regularity, we need to use truth table. And we need 2 bits because 2 is become 1 0 and 1 is become 0 1. Okay, so here is high bits, here is low bits, and the initial state is 0 0, and here is input. If we face and our input is only become 0 or 1 on each bit, right? So if the input is 0 and high bit and low bit will still be 0 0. And second state, if input is still 0, it will still 0 1. And next state 1 0 with input of 0, it will still be 1 0 because our counter is still not being larger, right? Okay, so if we want to add more, then it will back to our reset state. So let's come to next condition. If we get initial state with input of 1, and it will become 0 1. And next we come to here 0 1. If 0 1 then face a input of 1 again, it will become 1 0. And this state, if it 1 0 face input number of 1 again, it will become 0 0 because if it appears for 3 times, we want it to reset, right? So it back to 0 0. This is the key point. And based on what we have learned about the truth table, we want to calculate high bit and low bit. So this is first we need to find I assume that I want to calculate low bit. We find out the bit 1. If we want to calculate the high bit, first we also find out the bit 1. And for low bit we need to use this. For high bit we need to use this. For low bit again for this. For high bit again for this. This is our input. So now let's start calculate. For low bit it is reverse of high bit and low bit and reverse of input plus, or another low bit is reverse of high bit and reverse of low bit and input. Okay, so if we if we scratch our high bit now, it would become low bit and reverse input, or reverse low bit and input. And in fact, you can find that this means that low bit XOR input bit. Okay, So we have already get our low bit result to become reverse high bit and low bit XOR input bit. Okay, so next one is high bit. High bit is high bit and reverse lower bit and reverse input bit, or reverse high bit and low bit and input bit. Okay, so let us also find something from it. Okay, well, there is nothing we can get from this sentence, so we can just use this as our result of higher bit, even it seems like it is more complex equation. Okay, so this is our idea. Then we just need to return the lower bit, and that will be our answer of single number. Why? Because if we come from the 0 and add 1 times, and it will becomes 1. However, if we add one more and one more, it is still just 0. If it add one more, it is still just 0 because it is single number. And here again, if we come from initial state, if it appears for 1 time, and next it will still become 0 because that means that he is not single number. So if we want to find that the same way, if we want to find that still other number appears for 3 times, and while single number appears for 2 times, then you just need to return higher bit because he used 2 times to become 1 and then reset to 0 again. Here's M. He used 2 times to become 1 and then reset to 0 again. So the answer is our low bit. Okay, let's come to see our code to make sure the idea is wrong or right. Okay, so this is our solution. For each bit, we can get, okay, yes. So this I is our input, just like the equation we get from the truth table. Okay, here, right? Our idea is right. Then we can return low and get a high and bit high portion of solution. Okay, and why we need a temp low here? Because here you want to calculate the low. However, if we change low first, and the high bit depends on the old version of low. But if we change low to the, okay, I will use word, high bit, low bit, and old high, old low. Okay, so today our high bit depends on the old low bit. However, if we just calculate the result and put into the low bit in the first line, and it will change its result. And now if we want to calculate high with the low bit, it will become the result depends on new low bit, and the result of high will wrong. Okay, so we need to store it into a temporary variable first. For second line, we can depend on the old version of low bit, and then here put the temporary value into our low bit again. Okay, so this is first version. Oh, first version solution of truth table. So what is the second solution? Second solution, in fact, it is just I want to get a much more clear code, because this I don't like this temp. I don't want something like temporary variable in my loop. Okay, so now I just want to change truth table to solve such a problem. So let's go back to the idea again. And erase it. And we will take our low bit to here, 0 1 0 1 0 0. So previously you need to depend on the low bits in the previous state. Now I have already converted to here, so you just need to high bit just need to operate with the low bit at the same time and can get the result. So let us recalculate our high bit again. So it would be this line and this line. Okay, so high bit can be high and reverse low and reverse input, or reverse high and reverse low and input. Okay, so now we know how to make a clear code. Take out our low bit, and again we can get high XOR input. This is our clear code. So come back to our code. This is our clear version of code. Okay. Okay, so this is our fourth solution. From sort function and put it into group and test the first number is equals to third number. If yes, it is not a single number. If not, it is a single number. And second idea is similar to the first one, but it will manipulate on each bit. And the third one is take the state machine, and the solution is very worthy of for you to understand. Okay, So are you really understand this solution? And do you prepare to interview and use this algorithm to fascinate the interviewer? So here I extend the same problem. With most number appears for 4 times and single number appears for 2 times, please print out the single number. So uh, I will not talk about the code and the idea again because the idea is just truth table again. If you already understand what I'm talking about, then this question you can solve it. Okay, so this is the truth table about this extended idea, and again calculate the result of high bit and lower bit, and use this idea and write out this code, then you can get the single bit. And if you want to optimize the code without the temporary variable, here's another version. Although it looks like that is not so different from the previous code. So have you finished it? If you consider temporary a trash, just to optimize it. Okay, I wish my video can help you understand this problem specifically for the state machine and truth table. So if you still have a problem and want to take a look at the idea and the conclusion of this video, you can go to my blog of blog.onebunch.com, and for the code I will also paste in my blog. So welcome to subscribe me. Thanks.